Hey, this is David D. Hilstert with my physics police hat on, so watch out today. I'm in a nasty mood. I'm not going to take any junk from anybody, no lies, no uh, ideas from mainstream that we don't agree with. I'm not going to let anything go through, and also for the dissidents as well. But you've reached and you are watching Saturday Science Chat with the John Chappell Natural Philosophy Society and Dissident Sciences. Science. And I'm Dave D. Hilster. Hey, how's it going? Again, I want to welcome all of my subscribers from Dissident Science YouTube channel, and of course, everyone from the John Chappell Natural Philosophy Society, which is growing. We're getting more and more people here. It's really great to see you. If you have just recently subscribed, I thank you for subscribing. We have a great show today. We're going to be talking with James Maxlow. He's on his way here. He's in Perth, Australia. I'm here in Boca Raton, Florida. Yeah, the place where everybody retires. But I'm not retired. I'm working still. And thank goodness. And as a matter of fact, this is my fun hobby, like a lot of people. But I've been in this for many, many decades and have gotten to meet amazing critical thinkers along the way. And of course, I always like to start out with a little presentation, tell you who we are, what we're doing, and some of my own ideas about what's going to be happening, of course, today as well. Again, these are our Saturday Science Chats. They are sponsored by the John Chappell Natural Philosophy Society and the Dissident Science. You can go and, of course, visit us at naturalphilosophy.org. And that's our website for our worldwide organizations of hundreds and thousands of scientists cataloged as well, who are working outside the mainstream and who are doing amazing work. These are the Galileos, the Copernicuses, and the, I would say, Einsteins, but no, that may be not a good one to put as an example in the future. The Newtons, all those kinds of people of our time. So this is where you're going to meet and talk, be able to talk with those people. So also the Dissident Science YouTube channel. Again, we're broadcasting live. Well, there we go. Trying to move these slides. I never know. Click, mouse, button, I don't know. But the CNPS the mission is to be, we're an organization that above all promotes critical thinking without malice, to be an organization that supports, publishes, and promotes serious scientific work outside mainstream science, and of course, to provide a forum for open debate about modern topics in physics, cosmology, philosophy, and mathematics, to provide a forum for presenting serious papers and theories without fear of censorship. And of course, really important is we are run and controlled by our entirety by our membership, including the directors and everything. So that's really important. We learned our lesson 5 years ago about that. If you want to join in a community, we're getting new people all the time. It's great to see. This is our new website, so it's pretty new, but we've got already 50 people signed up for it. And you can just join for free, start watching or joining in on the discussions. We have many different discussion groups. We have many different people of many different areas, and the activity feed on the front page is sort of like Facebook, but it's obviously directed about our community and the different things that we talk about, like relativity and the Big Bang and physics and cosmology and philosophy, and expansion tectonics is one of them. So you want to join in if you can. And how you can participate, of course, is to sign up on that website, but you can also consider being a membership. And I would like to put out a shout out to all of our members and the people who are new. We do need people to become memberships. We're coming up in December. We have a big bill coming up, which comes out to be about $60 a month for our website. And we have bills monthly for our newsletter. And we have an online system for publishing, which we use for our proceedings. So here's one. We do have proceedings. So that we come up with normally yearly. We don't have it this year because of COVID, but those kinds of things do cost money. So please consider becoming a member. And if you just like us and don't want to become a member, you can donate. We have a donate button there. It is not appreciated. It is necessary. It is vital for us and our organization today. Because today, folks, this is where everything resides, especially with COVID, but this is where the communities are, and we're spread across the world, in fact. So you can, of course, post to our news about this. I post about our group and our YouTube meetings our YouTube and Facebook lives every Saturday. You can post that to your Facebook page and let people know, or wherever you are. So also, our websites, you should check them out. If you are brand new, you can go again to I talked about our community, but we have an online magazine, sciencewoke.org, which gets a good amount of traffic. And the reason is because it's got a lot of great articles that are written in like a magazine form about all the problems in physics and cosmology and mathematics and philosophy. And you can read them in a way that's very magazine-like. And also we have a Wikipedia using the same software as Wikipedia, but this one is about things outside of mainstream, which of course you can't get on to Wikipedia, because even if it's like Expansion Tectonics, it's looked upon as a fringe. I know, it's just, especially Expansion Tectonics, of anything that is in the dissonant world, that has more evidence than anything. And that's what we're going to be talking about today. And of course, we have our Chappell University courses in natural philosophy. And natural philosophy, for those people who don't know, is what we used to call physics. And the word physics and cosmology and a physicist is actually a quite new word in our language, maybe 100 years old or so, a couple hundred. Not a couple hundred, less than 200 years old. So it's a modern notion. And before that, it was called natural philosophy. And we're going to have of course, our university. And we have people lined up, including James Maxlow, who will be, has agreed to put up courses in Expansion Tectonics. Because I asked him, hey, James, are you going to be able to go to a university and teach this stuff? And he just laughed at me, and I guess that was the answer. But he's going to be creating a course online. We also have two other people lined up to put up courses, and those two people are Dr. Glenn Borkert. If you haven't seen and heard of him, you should look him up. Dr. Glenn Borkert, who is, in my humble opinion, the best philosopher of our time, of our generation. The Thomas Kuhn, way more than Thomas Kuhn. It's really, in my opinion, not comparable. Thomas Kuhn was really talking about the way science moves forward, but in this case, the philosophy of science, the 10 assumptions of science and infinity. If you check out our video from last week, we had an amazing interview with him. It was a really, really good session. So go back and take a look at that. He's going to be coming up and having courses. He has agreed to teach a course in philosophy. His philosophy is infinity and the 10 assumptions of science, which are really, really solid things, in my opinion, and many people's opinion. I got a little bit of commentary today. Of course, I always like to put it in. And we're actually making progress in advancing, did I spell that right? Advancing science, because I put these together, usually the half an hour before we have our talk, because they are fresh off the press in my mind. And you can see here are the little bricks building. And people actually pointed out to this. A lot of people who have seen this. So a lot of the people who are in the chat, I know people are chatting away there. I know Shockwave had asked me, did I see this? And yeah, there is a YouTube channel. It's a modest channel, about a little bit bigger than mine. It says See the Pattern. And this guy came up with a great video. We're going to be watching this video today. And that video is, let's see here. There we go. Major problems with plate tectonics. And he talks about 7 major problems in plate tectonics. And of course, that is something that is from a person who's really not known for this, but made some studies. His idea is to look at patterns in the world, and actually has James Maxlow in this. So we're going to be taking a look at that later today. I think we click this, and that's pretty much. Oh, did I miss something? No, I didn't. That's my commentary for today. We're going to be talking with James Maxlow today. He's going to be giving a talk on Expansion Tectonics. This is his 4th in the series. If you don't know who James Maxlow is, he is a retired professional geologist who has worked as a mining and exploration geologist throughout much of Australia. During that time, he returned to Curtin University of Technology in Perth, Western Australia, yes, on the other side from Sydney, and to study research and expansion tectonics, which he actually coined that word to be different from plate tectonics. And from this research, he gained a Master of Science degree in 1995, followed by a PhD in 2002. And he has actually said that it was very lucky that he was even able to do that, which is probably true. If you haven't seen his website, it's a pretty good website. You know, this style is a little, you know, a little 1990-ish, 2000s, but the information is just fantastic. So you want to go to expansiontectonics.com. You can check it out. A lot of great stuff there. You can see his models at the top there, which he builds by hand, which are incredible. And of course, in my opinion, the best geological book on geology ever written, in my opinion, again. That is called Beyond Plate Tectonics, and the subtitle is Unsettling Settled Science. And it's Beyond Plate Tectonics signposts that this is something more advanced than basic academic courses might offer. While the subtitle, of course, confirms our suspicions, the whole book is all revolutionary and new, unsettling to anyone who thinks there will be no major revisions in the Earth science. That's again a super understatement if you have looked at expansion tectonics at all. It's just as stimulating to those people who understand that scientific discovery will never be finished. And I'm supposed to. This is where I always put the stinger in. So I'm going to do that right now. I always forget that. So here we go. Oh, what am I doing here? I don't know what I'm doing with all these buttons, folks. I'm still learning all this system here, but I will have to say, James Maxwell's not here yet. I don't know. There was actually a change in time, so please don't go away because we're going to watch a video right now that has him in it. He's supposed to be here. I've been doing this for many, many years, but we're going to take a look at a video and talk about expansion tectonics here. Let me get to that one, and I may try to do this I wonder if I can do this bigger. Hold on, folks. We're going to make sure we get this right. Sharing the screen. Do not show okay. And I need to click on share audio. And I'm going to hold on. So what we're going to be doing is we're going to take a look at a video that came up this week that is quite interesting. Let me get to that here. I'm going to do it a little different way. I'm going to go to my history, take a look at that because I get to it right away. And I am going to get it enlarged here. And we're going to take a look at this. It's about 8 minutes, so. And it wants to go everywhere all the time. So we're going to take a look at this. And again, this video is from a website which I never really heard of. I like Expansion Tectonics, so of course when you're in YouTube, they'll suggest videos, and I saw this and many people saw it. And it was quite good. Here's a guy that's really not in this at all, is just looking at the logic of it, and let's take a look at what he says. And hopefully James Maxlow will be able to make it here. Oh, by the way, it is 11 at night there, 11:15 at night. I don't know if he thought the chime was the same and he just thought it wasn't going to happen. I did send him something. He may have gone to bed, but if not, we're going to have this next week. But don't worry about it. We'll have plenty to talk about this morning because plate tectonics in expansion tectonics is something we can talk about all day long. And so let's take a look at this video and we'll discuss. Let me know too if you will hear this.
There are many problems with the current model of plate tectonics, some small and some major. A lot of these problems simply disappear when we examine a model where the Earth itself is expanding rather than the continents moving. Let's run through the top problems with the current plate tectonics model. Number 1. The subduction of plates. There are many different versions of the expanding Earth model, and one of the main differences between them is whether they accept or reject the concept of subduction. It is clear, however, that they are both at odds with the concept of subduction put forward by plate tectonics. The main differences come down to how far down this subduction continues. Plate tectonics would have this going on for thousands of kilometers, which, as we have discussed in the episode What Drives the Plate Movements, cannot really occur. Recent high-resolution global mantle tomographic models provide images of subduction zones very different from the expected ones. The narrow high-velocity zones under the Asiatic Circum-Pacific arcs appear not to be prolonged towards the lower mantle, but instead deflect horizontally into or under the 400 to 700 kilometer transition zone, and a horizontal flow must be admitted. In some cases, it even appears as if the leading edge has an upward motion. This presents a problem for the normal plate tectonics. As the plates reach a depth of 700 kilometers, its own decreasing buoyancy should pull the rest of the plate with it and plunge it towards the mantle. But here we are seeing something very different. The motion is not downwards, in some cases it is even upwards. Experiments conducted with different kinds of slabs show that stiff slabs tend to curl like wood shavings, and weak slabs tend to undergo retrograde subduction, none of which fit with the standard tectonics model. High-resolution images of the mantle plumes under the major hotspots show that the plumes can be followed up to at least 800 kilometers in a nearly vertical manner. With little to no deviation, this strongly suggests that there can be no convective circulation processes going on. Number 2. Distortions in the reconstruction of Pangea. When we examine the reconstruction of Pangea, there are certain artifacts that present plate tectonics with some major problems. Large tears are observed in the reconstruction of Pangea that appear crossed by huge inlets like the Tethys Sea, the Arctic Sinus, and the Austral Sinus. Another problem is that the remainder of the Earth was covered in an ocean which covered more than one hemisphere. The age of this ocean is greater or equal to the Triassic. This means that a vast amount of oceanic lithosphere needs to be completely consumed during the post-Triassic times. Add into this that we should expect to find the remains of this pre-Triassic floor in each of the many tiers or sinuses, yet we do not. So in order to get around this problem, they need to devise even more complex models to explain how the oceanic floor in each of these sinuses was removed. Number 3. The coincidence of ocean floor ages. Another problem relates to the maximum age of any of our ocean or seafloor beds. Their maximum age is the Jurassic, and this presents a major problem as the ocean floors do not move at the same rate. The Pacific one moves at 5 times the rate of the Atlantic. If the Pacific had moved at a rate just a little slower, it should have been sufficient to expose the Triassic floor bed. A rate just a little faster would have completely erased the Jurassic seafloor bed in the Pacific. Yet, we have the uncomfortable scenario that all the seabeds have the same maximum seafloor bed age. Number 4. The triple point paradox. Understanding the concept of plate tectonics is normally explained as a simple process. One end is being subducted while new material is created at the other end. This movement occurs for each plate and causes the continents to move. The problem is that the plates are not aligned in simple slices. Instead, there are many plates that have 3 boundaries, meaning plates have to pivot. Plate tectonics prescribes that the motion between 2 plates is governed by a rotation around the common pole. The problem is that when we deal with 3 plate boundaries, each pair of plate boundaries requires its own pole, so 3 poles, which clearly creates a paradox, as you cannot rotate a plate around 3 different poles, meaning we cannot apply the rules of plate tectonics to these situations. Number 5. The shape conformities in the Pacific. One of the arguments for plate tectonics was the conformity between the outline of Africa and South America, and we can easily see this in the reconstruction of Pangea. The problem is that we can also find this shape conformity on the other side of South America with Australia and New Guinea, and this is not possible in the standard tectonics, as these continents were nowhere near each other when they were part of Pangea, and are actually moving towards each other. The only way we can end up with conformity on both sides of South America is if the whole planet was smaller and these were all touching. Number 6. Paleontological Paradoxes. Further problems persist with the idea of a Pangea when we examine the flora and fauna. There is a strong similarity between the Ordovician nautiloids of Tasmania with the Asiatic and Laurentian ones. When we examine the Silurian, there is a strong correspondence in the similarities between the planktonic floras of the Canning Basin in Western Australia and those found in the USA. The Devonian vertebrate fossils of South America have been found displaying close similarities with the correspondent faunas of Antarctica, Australia, and South China. These facts testify to the fact that these locations must have been much closer together, which they cannot have been in a Pangea reconstruction. Fossil bones of the Triassic reptile Lystrosaurus have been found in Gondwana in India, but also in many places in Eurasia, which should have been separated by the wide Tethys Sea. Many flora species typical of East Asia have been found on the opposite side of the Pacific, while the East Pacific Barrier was at its maximum. The only way they could solve this problem was to have a series of smaller continental fragments which started a trip from East Asia near the equator at an unusually high velocity. Number 7. India's movement. The original position of India when it was part of Pangea versus its later location. If India had indeed travelled up and towards Eurasia and turned in the process, we would expect there to be magnetic anomalies compared to its resting place. No linear magnetic anomalies have ever been found. In the next part, we will examine the main problems of dramatic changes in the climate and the wandering pole and see if an expanding Earth can bring a different perspective to this. On a final note, I would just like to say a huge thank you to all of my Patreon supporters and those who support me through PayPal. If you are interested in joining the Patreon, then there's a link down.
Hey everybody, I thought that was super interesting. I never saw some of those arguments, especially about the subduction. I didn't know they had really information about the subduction. I don't know if I can go back here. Let's see. Quite interesting when he's talking about subduction, these sort of graphs here. And those graphs show, you can see up here at the top, that these are supposed to be the plates going under and subducting. But what happens is what they're finding is what they're saying and how it works isn't the way they thought it would work. And so one of the arguments, of course, one of the giant arguments against plate tectonic, expansion tectonics is subduction, that you have subduction, so how could you have an expansion? Now, of course, you got a bigger problem for those who don't know is all around Antarctica, you have only expansion. So how could you have only expansion around Antarctica with no subduction, and this is mainstream plate tectonics. And how do you explain that? How would you then say the Earth, even at that point, would be staying the same size? And it won't. It just won't. The Earth will kind of move down from that. So the whole idea of subduction being what's really going on here, and you can also see this is another part of the subduction. Again, subduction is sort of the idea. Again, is that you have a plate here. You have two plates, and then one plate will go down underneath another plate and be subducted. And the reason you have to have that is the only way you can keep the radius of an Earth got one of his models. This is an actual model he built here. Too much light. But while these expansion joints, you can see there's a, while the Earth is expanding, that has to be subducted for this to stay the same radius. And if you look right over here, you're going to see this is the depth in kilometers all the way down to 1200, where they're actually looking at what's going on down under that. And they're finding out that, in fact, what the theory says for plate tectonics and what's really going on, and this is at the border of a plate I believe it's a ridge there, that it is not conforming to what plate tectonics says. And again, here is another, let me get back here and show you here. I want to show you Antarctica. Now there's Antarctica. Now if you look at Antarctica here, you're going to see all around it expansion right there. And the expansion is that sort of pink in this case, and it's all around it. There is no really subduction going on, and there's a real problem there. How can it? Oh, you can see James signed this for me. See, there's James' signature right there, one of his handmade models here. And you can see that if it's the case that this Earth is supposed to stay in the same radius, why would you have expanding all around? Where is that going to be subducted? Where on Earth, literally, where on Earth are we going to be able to eat up what is being built? So all of those expansion ridges you see there have to be built. You can see the expansion ridges here in the middle, and then here's the coast of Africa, which is upside down here. But what will happen is you're supposed to have subduction going on, so it grows here, and then it's supposed to subduct there. And the problem is with that idea is that's not what they find. What this guy was finding. He's basically an independent kind of guy, and his idea is that I'm going to take a look at the arguments for and against expansion tectonics. So that was his first argument was, in fact, let's see here, subduction of plates. And that's, of course, okay, going forward here. Now the second one is, and I think here's another thing. This is the way subduction would really work. And it doesn't even work according to, these are like models of subduction. It doesn't even work according to the way plate tectonics, again, says it should work. So that's very problematic. And again, he's looking at inside the Earth. So we have pictures of quite far inside the Earth. Let's see here, subduction of plates. Okay. So one of the other problems is, of course, Pangea. Pangea is the idea, and this is the construction of the way people in plate tectonics say. In fact, my daughter, who was learning this, knew that I didn't subscribe to plate tectonics. But, Dad, she goes, Dad, I've got to learn this anyways. I've got to test on it. Well, the problem with Pangea is we can see how it all fits together. The pieces in the Atlantic, but of course the Pacific also comes together as well. You've got the problem of India down here. You can see this right there. And India is supposed to be up here. You can see this sort of like piece up there. It's just the absurdities of the way everything has to work. There are just so many problems with Pangea, so many problems with expansion with plate tectonics. The other problem, of course, he talks about is the flora and fauna, how those things, when they come together, he mentions that a little bit later on. And, this is very interesting. I didn't realize this, but if you look at this, you can see at the bottom here, it says credit to Giancarlo Scalera. Well, Giancarlo Scalera, when I was doing, my friend and I, Greg Bolk, were making our database of all the dissidents and critical thinkers outside of the mainstream. We came in 2008, I came across Expansion Tectonics via Neil Adams videos, and then I went nuts, and then I met and called up James Maxlow, and I got to meet a lot of people. It got me on my journey of being interested in expansion tectonics. Well, we were gathering lots of people, and in fact, if you go to our database, if you go to db.naturalphilosophy.org, I think I have that here. Where do I, right here. So I'll put that there. If you go to db.naturalphilosophy.org and look at expansion tectonics, you're going to see all the people. I think there's as many as 80 people who have been involved in this theory over the last 100 years. And Giancarlo Scalera is an Italian who actually used some of his knowledge of expansion tectonics in his real job of looking at minerals. I think he's a mineralogist. I'm not sure, but don't quote me on that. But he's the one who came up with this whole idea of, okay, we have, let me get rid of this here. We have, oh boy, there we are. I think if we go a little further, there we go. That when you're looking at the way the plates are expanding and the way the floor is expanding, they say there has to be rotation. So if then the rotation is required by plate tectonics to even try to make sense, which is it does very poorly on. And that it turns out to explain using their own rules of plate tectonics, Scalera points out that these continents and their pivot points, that you would have to have a continent with 3 pivot points to explain these sort of, when you see these the way the expansion is going on, you can see these sort of, I don't know, cracks and sort of bands, I guess you would call them. And they're trying to explain, well, why those exist. And so that's interesting that Giancarlo, I've never met him or talked with him. I think he's got to be pretty old these days. And then, of course, we talk about, he's talking about the Pacific fit. The only thing here is I think he's got this a little bit wrong, but it doesn't really matter. There is a fit that goes on in the Pacific, and the reason you can't see it is what is called a blind spot. And the blind spot is meaning if you look at a globe, and I'm going to get my globe, but that's why I have my globes here. Let's go back here. Let me show you. Yeah, I can take it out. Woohoo! Hold on. I'm going to bring it down so you can see what I'm doing. Trying to take it off the... Yeah, there we go. I've gotten the Earth off its axis here. But what's interesting, of course, is if you look at the globe, as many people say, it doesn't take anybody, even like a school child, can see that in fact these 2 continents fit together. And if you look at it, you can see literally, you can see the bumps here on South America, Rio de Janeiro, where my wife's from, and you can see over here the exact same pattern. In fact, one of the things that if you haven't noticed, and I actually noticed this, and many people who discover this sort of on their own notice it, that if you try to just take South America and you cut it out and put it next to Africa, it actually gaps. And the reason is because it won't fit on the current radius. The only way that South America fits really closely together with Africa is if you put it on a smaller radius. So that's another piece of evidence that would point to a smaller radius. Now, again, let's take a look at this side. Again, you can see how that sort of fits together. Now, if you go around the Earth, now take a look at this side. You can't see anything, and so you would imagine this doesn't show us anything about how anything fits together. Well, it turns out that if you look on this side of Australia, where are you here? Right here, the side of Australia, and this area here, this whole area right here, whoops, right there. And if you look at South America, way over here, that those 2, you can start to see some fits together. You can see actually how South America's image is over on this side of the Pacific. And you can almost see a shape, like see the ridges? You can almost see South America sitting there. Now it's really more it's not because it's left over from moving away from it, because that's not the way it works. It doesn't work that South America moved over like a pancake on a skittle. It's not that way. But it turns out what he's saying here, and this is very true. If you look at this, you can almost see no land mass at all. And the reason is this is expanding at about 18 to 23 centimeters a year, which in geological times is extremely fast, whereas the Atlantic Ocean is only expanding about, I think, maybe 6 or 7 millimeters a year. Is it millimeters? I think so. A year. So that's trying to measure that with satellites, and every people say, oh, we should be able to measure that and all that. But yeah, you can't. Another interesting thing, I'm just going to be talking here. We're right there is Iceland, right? Iceland is right on the ridge, the expansion ridge. There's parts of it there. And if you look up the expansion ridge in Iceland and underwater, the water is super clear there. Now, why would the water be super clear at an expansion point? Because water comes from, according to Maxlow, Dr. Maxlow, water comes from the mantle, and the mantle itself, the rock, has water inside it. So whenever mantle, you see it coming up, like in volcanoes, there's water inside that. So where does water come? How did this planet become so blue? Well, the water comes from the mantle. It's inside and comes up with it. And in Iceland, it is super crystal clear. So this is brand new water that's coming along. So that's what he's talking about there. I love this. Now I got to find how to put it back together, which I won't. I'm going to put it right here. Oh, this will be cool. Whoa! I'm sorry. That was off balance there. That's maybe I can just set it down. I need to get a ring for this. Yeah. Anyways, I'll keep it in my lap. All right. So that was another thing he was talking about, and then of course another aspect he was talking about was flora and fauna. Now, this is a really interesting area, and this is one of the reasons I think we need to, as a community, come together and get Google Earth and see if we can make branch off Google Earth software-wise and make it so that we can put time on there and then put in the radius of the Earth during those certain times. So that's one of the things. But what he was talking about is the flora and fauna, where you have where you have the flora and fauna that are very separated and can't be explained in a Pangea reconstruction, whereas on an expanding Earth they make sense. And we have lots of evidence of this. So that's another thing he did talk about. So anyways, that's a really interesting, oh, I'm not even showing that. I am so sorry. I stand here and I don't know what I'm doing when I'm talking about it, and I'm acting as if you can see this. So again, this is Pangea Reconstruction. Actually, Dennis McCarthy, a critical thinker, gave us a talk, one of the very first talks back in 2008, where he talked about the flora and fauna. And I'm going to have him back on. I'd love to have him back on and talk about his research on that, where he would find like flowers that if the flowers fall into salt water, they die. Their seeds die, so there's no way that they could, float across on something. But it just so happens, and even if, let's say, a bird took it, it only grows in certain regions, but where they grew, some of these flowers, for instance, were only growing in one area in the Pacific and one area in the Americas, and the expanding Earth was one way, an easy way to explain those anomalies. So that's pretty cool. Anyways, that's what I have, and I do apologize again, because I believe what happened, and I was worried about that, but last time he showed up, is that right now we were 12 hours different with Perth. If I believe that's what I have here on my watch. Let's see here. Perth today. Yeah, Perth is right now at 11:40. It used to be at 10:40. He probably came on an hour before this and was waiting and says, this isn't here. I don't know, but I do apologize. But we are here. So let me take a look at some of the questions. But first of all, since we have a more open session today, you can come, if you do want to talk with us, you can come on live by typing into any browser live.naturalphilosophy.org, and that should bring you here. We change it every week. Every week we have a different broadcast. We use StreamYard, which we again pay for. And again, if you're considering of supporting us, it's a vital support that you guys bring us to help pay for us our ability to do all these things. But every week we make a link, and I link it to live.naturalphilosophy.org. And sometimes people said, "Oh, now I understand why some weeks it wasn't working because I didn't update it." But it is updated today. And if you want to come on and discuss with me, if you have any questions or want to discuss something, I'm open to lots of discussions about different things as well. I happen to know a lot about a lot of different subjects. But regardless, you can come and join in. So let me take a look at some of the chats and comments here and see what people are talking about. Let's see. This is when you lose people if you don't keep talking and make sure there's all kinds of things going. Have anyone tried making a globe? Oh, here we go. This is a very interesting question, actually, and I tried it. In fact, here we go. I'll give you an example. I was trying to come up with an experiment for my daughter's school when she was in elementary school, and this was the idea. The idea was to take this globe right here, and take all. This was pretty cool, actually. So, Scotty, look at this. I'm going to put them up to the camera at the same distance. This is the globe, and this globe, believe it or not, represents the time when the Earth was this size and the continents cracked up and it started expanding. So I'm not kidding. This size. Oh, now they're the same. See, it's all relative. But no, my camera's right here. Put them together. This is the size. So the idea was I would take, and I did. I bought clay, and I put it on top, of the continents, and then I wanted to put it on a smaller orb. I think this is actually a little small. I think I had a different globe. But regardless, the idea was have the kid. Oh, wait a minute. I think it is. Look, it's got clay on it still. But the idea was if you calculate the size of the Earth when the plates 240 million years ago, that when they started to break up and that was the size of the Earth, probably more like about this, then you should be able to put clay on all of these. And I was going to have the kids take clay with different colors and put it on here, and then take it off, peel it off, and put it onto a smaller globe to show you that it fits. Now, I thought that was a really great idea, and I don't know what happened with that idea. I think I don't know what happened, but that was my idea, at least. There are YouTubes out there, and I will have to. Let's see. Do I have? Oh yeah, I have. This is a YouTube. This is a page up here. I will see if I can find expanding Earth balloon. There's actually some people who do that, which is pretty interesting. Expanding the universe on a balloon. No, that's not it. I will see if somebody can find that. Maybe stick it in the chat. That would be good. I can show you that. Let's see. The only problem I see with Maxlow theory is the solid core Earth. It's hollow. I guess the only thing I would say about that, Paul, is that according to seismologists and people who do study and know about geology, that's not what they're getting, and they can go pretty far now. Of course, we can't drill down more than a couple miles, so we actually can't get there ourselves directly. But the only problem with the idea of the hollow Earth is that all of the evidence shows that we don't have a hollow Earth. I can't remember about that, but the truth is, to be honest, and this is the way we should be critical thinker. If I'm policing myself, I cannot tell you for sure that's not true. We have only evidence that we can look at. We can't go directly inside. We can't X-ray it. But according to earthquakes and those kinds of things, I believe that they do have things bouncing off, and they can calculate its hardness or even its mass, that kind of thing. But again, I don't know. We can never say never to anything. So, particle model could be Brownian motion and density randomly created planets. Okay, well, you're talking about the creation. The particle model could be Brownian motion and density rule, randomly creating planets or stars. Seems infinitely amount of matter. I guess we're talking about one of the things is about expansion tectonics are the planets. In fact, I was watching a video about Neptune the other day to find out about that, and it's got a solid core as well. The idea there is that they expanded, and the Earth will eventually turn into a gas giant. That as everything keeps as the mass keeps growing and stuff keeps expanding, and we have the release of water and other methane and those things, eventually those equilibrium will get to a point where the Earth and its atmosphere will turn into gas. It's not going to be good for us, but this is like probably hundreds of millions of years into the future. That's one of the things James Maxlow does do, is he did a model 25 million years into the future. So what would cause the process suddenly to start expanding? Now that's a really excuse me, that's a really good question. And there's been a lot of ideas about that over the decades and decades and decades, because people have thought about that, because the expansion is actually exponential. If you go back and watch, or you take a look at books, I think I got his book here. Is this it? No. Anyways, his book on expansion tectonics, in there he has a picture graph. Here it is. I'll look for that. But he has a graph of the expansion. Of course, expansion doesn't happen in a linear way. It happens, it's been happening in an exponential manner. There we go. It takes a little time for it to, oops, wrong side. But you can see there, that's expansion. It was extremely small. It was in the, not even millimeters. Per whatever, it's very small millimeters for eons, and then all of a sudden we have been getting a bigger expansion. Now the question is, and the $64,000 question for people as old as I am, is that expansion caused only by the same mechanisms? I mean, just if you just think about it critically, critical thinker, put your critical thinker cap on. The way I would look at it is, as it's expanding, things are changing. The amounts of molecules and atomic atoms and how they are, the pressures, the amount of mass, all of those things combined are going to cause the system to change. It's not a constant system with simply mass increase. You're going to have more, water is leaching out. Gases are leaching out. You have oil also there. There are many things that are happening. And so the idea that the expansion is going to happen only because of one thing, of mass increase, and that there wouldn't be some type of nuclear event is a folly, in my opinion. My opinion is, for those who do believe that the Earth is solid and not hollow, and its core is very hot, it could be a nuclear event that at that time, at the time when the continents started breaking up, it started going faster. That's basically the way you would see it. And it turns out that a lot of intuition that we may have, especially about looking at what we think how stars evolve, of course, would be to say that there was some type of maybe nuclear event that started the expanding in a more, more exponential way. So that's a $64,000 question, but I would say the answer is probably a combination of numbers of things. I don't think there's no way that the system could stay the same during this entire time. And I do think that the exponential part does have an explanation, and someday we may have that. Here's one. The sun is making protons, electrons, and all kinds of matter arrive here. The sun is the only thing I would say about that is the idea that they're making protons and electrons. That's possible, but our models of the universe with quarks, many of us who don't believe quarks exist, that it's just another folly of particle physics and the way they do their science, which is a whole nother story. I'm going to have to get Alexander Unziker. If you haven't read The Higgs Fake, a must-read for everybody interested in science, because you're going to find out the way that the people at the Large Hadron Collider and other particles accelerators do science and do engineering and do software even is a travesty. It's not. Most engineers and software engineers who are serious would not stay in a place like that for more than a couple of days because of the way they do it. But again, going back here, we're talking about protons and electrons and quarks. So the whole idea that quarks are really the building blocks of these, electrons are supposedly don't have building blocks, protons do. Regardless, I think maybe more of an accurate statement here, 635574, is that I would say, the sun blows apart atoms and into their subcomponents, and those get shot out. And the mass of most of the mass of an atom is the nucleus. That's where you get most of the mass. So, in other words, to gain mass in the Earth, we have to have more protons or nuclei. I'm going to call them nucleons, because there's some dispute as to whether a neutron and proton exist. Dr. Lucas, who actually has friends in the particle accelerator business. He knows Dr. Bill Lucas. His work is on the putting all the forces of nature into one equation. He says that the evidence for two different types of nucleons has really gotten less and less. So what I would like to say, what we know today, being the physics police, saying I'm not going to tell people things that are, in my opinion, conjecture, but we do have atoms. They have nucleuses. We do know that. There are particles in there. We'll call them nucleons, and something that goes around it, which we call an electron. And so, there's here's the nucleus and something goes around it. That gets blown apart in the sun. That gets thrown out into the universe, and then it can be recaptured. Of course, some will say it's captured by the Earth's magnetic field. James Maxlow says it's captured and put into the D layer of the Earth, that they have different. They have the mantle, etc., the core, and then there's a D layer. I guess I'm using the wrong term. So that's one of the hypothesis about this. So magnetic fetting the same group of particles because of what it. I don't know if this is related, but I would like to hear more about how particles produce different phenomena, electrical or light or magnetic gravity from the same particle. What causes condition of being in different ways? I'm going to take this just because it is. I think it's about our particle model. The answer to that question is infinity. In fact, I saw somebody talking about the infinite universe, and they were talking about how the way I would describe it, the reason you have particles behave the way they are, the atoms, this is just an idea, but I'm not the only one who thinks this. There are people, I'm telling you, sort of the bleeding edge of critical thinkers right now, the idea of fractals. Here's the way I would put it. When you look at a fractal, we're looking at a fractal and we see patterns in it. But if you go into that fractal really small, you see different patterns. And if you go smaller still, you see different patterns. Well, that's the sort of the way the universe in a lot of people's minds work. There are different there's no ultimate particle. And there's a lot of problems with having an ultimate particle. And the ultimate particle would have to be magical because it would have to start self-organizing in making the universe from no reason at all, which is one of the things you're talking about here. And if you have an infinite universe, all you can say is that the atoms come together and work the way they do because of the level below that and all the forces below that and those things below that from the forces below that. So we just happen to live in this area of the universe, what we call unicosm. If you look at Borchert's work, we live in this unicosm, not microcosm. Microcosm below us, macrocosm above us, but the unicosm around us, and everything in this behavior is supported by the level below that, and that level, those levels are the levels below that, and on, turtles all the way down. So that's one of the explanations philosophically and also physically of how we can have things behave in the way they do, and it is because everything below it causes that behavior. So I did see somebody talk about that, and they talked about it in more waves, more like an ether theory, where they said the waves at this level do this, and the reason they do this in this level is because of the level below. They didn't have any, I don't see how you can get a mechanism between those two, in my opinion. I can't find that with ether. That's why one of the reasons I don't do that is because how to relate those levels. But that's a very, oh, there he is. There's Dr. Charles Lucas. He is, I was talking to people about that, and he was talking about, I remember him, he was given a Lifetime Achievement Award. He does talk about, I think, the decay of gravity being the cause of mass increase. It's a totally different idea, but he's got really great work. And so he's here, and he's the one who, I remember talking about that the nucleus of an atom doesn't have one of the particles. I don't know if it was neutrons or something like that, but I want to welcome him here. Let's see. Such large mass of gravity change orbit also cause huge associated particles and a dramatic increase in temperature. So I guess I should put these up while I'm talking about it. Such large gravity changes to orbits also in turn cause huge associated change in the planet, such as dramatic increase in temperature. Yeah, there's a lot of changes. My mentor, Dr. Riccardo Carrizzani, his calculations, and again, this is his work, said that the perihelion advance wasn't from special or general relativity, but it was from mass increase. That is, if you increase the mass, then you get a perihelion advance that slowly happens. So there can be a lot of different things. See, talking again, if you're looking for James Maxlow, he is not here today. It seems like in the time change, which we had recently, he probably came. I should have checked on that. That was my bad. I assumed he knew about that because I'm sort of, can watch it on my watch. I know what time it is there, and it would have been pretty late. So we will set up another time for him. We're sort of opening this up. We are talking about expansion tectonics. We're going to try to keep to that there. This person talks about structural atom model does just explain two protons with an electron as a replacement for the neutron. Again, that's, write about it, write papers on it, show us the idea, how that has, indirect evidence or whatever for it. That's what organization is for. We'll listen to anybody, but, it has to be somewhat organized, not just ideas in your head. We need to, everything has to have some kind of basis, but show us, write some things up, write a paper about it, and we'll be happy to put it into our next proceedings. And that's what we're all about. Let's see. I'm looking at the comments again here. We do have our green room, or what I call the green room, but you can come talk with us live here as I'm looking through the comments. The movement of electrons are all charged particles, and gives rise to magnetic fields and gravity. Okay, we can talk about this. We did talk about this a couple of weeks ago, but again, if you want to join us, and that is, in fact, this group here with Franklin Hugh, who happens to be in our green room. I see him lurking about there. He's having withdrawal symptoms. He's saying, Dave, you're driving people away. And we're doing pretty good, actually. We have 40 live people here. We got 24 from Dissident Science and 14 from John Chappelle. And oh man, I went to the wrong Facebook page today, and I apologize for that. I click on these things, and we're broadcasting to the Facebook for Dissident Science. So I welcome people from Dissident Science. I'm sorry, it should have been gone to our Facebook page, but we have most everybody through YouTube. So, anyways, I want to say hello, shout out to Franklin, and the people that have been here for many years have been talking about movements of electrons, and all charged particles give rise to magnetic fields. And if you watched my talk, and I would highly recommend you look at that, I did a survey of dissident scientists today, and I mentioned a lot of the people who are in organization, and some that are here actually today. And James Maxlow was one also listed. But I did list 5 models today: Glenn Borchert's model, Jeff Yee's model, the energy wave theory, Glenn Borchert's the infinite universe theory, also a new particle model, ether theory, I'm sorry, another ether theory by Laurie Gardee, and another ether theory by Yanel Duneau, who actually, in many of our opinions, has hacked what magnetism is about, which is flowing particles. And so if you look at that, all of those 5, in fact, I will go and, while we're talking, I can find that slide and put that up. I've got them here. What am I talking about? The Saturday morning, I've got to figure out which one it is. That is one that I gave, and I have that talk somewhere. But the what I'm babbling on about is that, in fact, the today's modern theories are theories that do not include charge. So let me see here if I can find that talk that I gave. And I'm not finding that right now, but I will try to look for that. But I have 5 theories, and I have check boxes for each of those theories. And on those, included in that theory, in all 5 active theories today, none of them have charge. So what does that mean? Well, it means that people are tired of the idea of charge, and we have literally drove ourselves around in circles. That's my opinion and many people's opinion. Is the electron, it's got a charge. Well, what is charge, which no one ever says? And when an electron moves, is it creating the field? Is it influenced by the field? Is it the field? And those questions have been bantered about constantly. And of course, we don't always have an answer for that. So, like I said, the ones today are here, dissonant slides, words of science. That's not it. Come on, David. Saturday morning, CPNS chats. Come on, science chats. Nope. I will try to find that though for everybody. Anyways, we have some more comments here. We'll keep going through the comments here. Oh, here's one. Hello, Bill Lucas. When can I buy Volume 2 of the Universal Force? I believe I have that right here. Here it is. Well, I don't have Volume 2. I do have Volume 1. Universal Force, Volume 1. And I don't have him. I have one where it's signed, actually. And you can read it. Modern science is built upon 3 pillars: Maxwellian electrodynamics, the Copenhagen version of quantum mechanics, and Einstein's special and general theories. These were all developed under philosophy of existentialism, which is based on idealizations instead of physical reality. So Dr. Lucas, in his book, shows how to perfect the union of axiomatic empirical scientific methods in order to derive an improved version of classical electrodynamics, incorporating the principle of conservation of energy instead of a vector potential without incorporating point particle idealizations. So yeah, it is. He does talk about a lot of things. Very interesting book. If you can, I believe this one's available. So if you look up Dr. is Charles Lucas Jr. Universal Force. Very, very interesting book. Again, it's built on I believe charge is one of the parts of that idea of his work. And like I said, many new how do you say, new theories out there and models do not have that. And I'm trying to find that while we are looking here. So I also have people in our green room. So if you want to come up and say hello, discuss something, that would be great. Let's see. Charge is here we go. Charge is a metaphysical principle, but it's what makes the universe infinite. It will go all the way down. Well, I'm not sure what that means. The words get a little bit muddled because metaphysical has a lot of different meanings, especially in the world. Well, I'm a linguist. My master's in linguistics, so I care about what these words mean. And metaphysical is something that actually Dr. Glenn Borkert reinterprets to be a something that used in the physical world, whereas metaphysical oftentimes is something in a dimension that's a different place or something like that. So I'm not sure what you mean by that. But let's see. Here's another one. Electricity is foundational, but it's polar. Electricity, electrical part of the universe is very interesting. What that is exactly depends on, you have to have some type of model, of course, to be able to say that. This is highly agreed upon in the how do you say, the dissident community, and I absolutely agree with this, and a lot of people do, that it's a fantasy. Relativity has a lot of problems. It's basic assumptions. If you watch my movie Einstein Wrong, you will see in there Dr. Eberly Spencer, who stands in front, who has a degree from MIT in mathematics and has studied relativity for quite a while, and electrodynamics. In fact, that was her specialty. And she basically said that Einstein had a number of assumptions, and one of them, that speed of light is constant, which it's not, and that that Maxwell's equations were correct, and they were not. That was her, how do you say, assumptions, or how do you say, her take on everything. So that's pretty interesting take. But we have many. I think in our database we have over 2,000 books and papers on why relativity is wrong. So that is you can find that. You can find that in the database as well on our website. So we do have somebody. Bob Gray is here. I will bring him up, and we'll see what he wants to chat about. And here we go. Hey, Bob. How you doing?
Hi, Dave. Thanks.
Good to see you. Thank you very much for coming on.
Not a problem.
What do you want us to chat about?
Yeah, I wanted to let you know that there is also a private chat with this StreamYard, and some people, myself particularly, puts comments there. You might want to check that occasionally.
Yeah, funny, they don't allow me to put those on live.
Yeah, weird.
Yeah. So go ahead.
The question that I put in there is, where is the book, that Maxwell book on the plate expansion? It didn't seem to be available through Amazon.com. Is it only available on his website? Or
that's a good question. It was supposed to be.
I've been looking for it and I can't find it.
And I don't even know. I know how I got it. I think he gave it to me.
Oh, well,
when he flew.
If you know the author, I mean.
Yeah, that's of course. Yeah, he wrote into it. So yeah, well, that was very lucky because it turned out that we had a donation for our conference. But yeah, that's really shameful that we can't get that. And he's working on it. It's just really tough.
Okay.
So yeah, that's something I will ask about that. We need to get it maybe in ebook form, but it is worth it. So any other questions?
Yeah, the other
comments?
question I had was these theories that do not include charge.
Right.
There's particle models and so forth. I'm wondering if it's just a language issue. Okay, so I'm not going to call it charge, but I'm going to have this particle interact with this particle, and they're going to move in a certain way. Well, that's charge if you label it that way. So is there really something fundamentally different, or is it, okay, I'm tired of using the language of charge and standard physics, I'm going to call it, raspberries.
Right.
I don't know. And it's a raspberry forest, but it's doing the same thing. Because it's, after all, it's the physical reality which I'm trying to describe with my model. And the model includes the language along with it. So I'm not sure what to really make when you say, or other people say, my model does not include charge.
Mm-hmm. Oh, that's a very good question, and there's a very good answer, actually. The problem is when you look at the word charge in people's models, it turns out that you can't pinpoint it as something that's consistent. What you see, for instance, let's take Coulomb's law. Coulomb's law looks exactly like a gravitational law. And in fact, that's exactly what our model says. It's gravitational force. It just happens that the particle for the gravity that causes the moon to go around the sun, and this is just our explanation, okay, it's the same it's the same force. It's just random particles going in different directions that cause a gravitic force, and therefore. But the charge at the Coulomb's side versus the charge of electron in a field, or the charge, another one is the atomic charge. When you look at it, what you find, and what I've found, is that you can't find a consistency to say that the thing itself can be a real notion in some sense. That's what I would say to you. That is, you can't. If the idea is what you're here, I think another person said that. It was Ian. Ian said this. He said, "Well, I'm okay. I understand that there are models without charge, but I'm okay with charge because it perfectly fine describes." And boy, all of us who are just trying to describe the universe without charge will disagree vehemently with that. And the reason I would disagree with that, and I would say to you, Bob, is that if that were the case, we've been thinking about charge since Benjamin Franklin. Benjamin Franklin came up with the plus and minus. Right. So we've had hundreds of years, we've had hundreds of brilliant minds working with the system of charge, of positive and negative, with fields, with electric fields, with magnetic fields, with the electron, with the positron, with polarity with molecules, which is really hard to figure out, which is basically an attraction, what they call a positive and negative. And the problem is that we're not coming up with an explanation that is consistent, other than that we've made something that magically pushes these things there, to and from things. So when you look at it, the easiest one for me is the argument that has been going on for hundreds of years, and that is, does an electron, a negative electron, is that creating a field? Is it part of a field? Is it influenced by a field? All of those things make charge so nebulous that we can use it, we talk about it, but it doesn't seem to give us any indication of something consistent to say that this translates into the physical world as this. And I think the reason, again, we can just, here's one of the problems. My dad, he's an electrical engineer. He's working with our particle model. He's going from being an electrical engineer, which I would imagine, if anybody believes in charge, electric engineers will believe in charge, positive, negative, batteries, power sources, components where you have things where charge and flow are very important. If he can go from the idea that, yeah, this is a totally arbitrary system. If you look at electrical engineering, the equations for electrical engineering, probably the most important, the most advanced engineering that human beings have ever come up with, right? The electrical engineer has created everything in our modern universe. Everything we're using today is done by manipulating what we call electricity. Yet we call electricity as the holes left behind, current are the holes left behind by the electron, which has a charge. And so
a particular model, but let me push back.
No, wait. That's in the mainstream model. That's
Yeah.
not any particular model. That's what, if you go to college right now, go to Harvard and ask a physicist, he's going to say that the current is the flow, is the movement of holes left behind by electrons going the opposite
Yes.
direction.
Understand. I meant in the standard model, in
Right.
that particular model, not the particle model of you and your father.
Or someone else's model. Right.
Right. Okay. So how then would you or these other people that say no charge change Coulomb's law? Or do they? And if they don't, then what do they call these things that in the standard formulation is a Q1 or Q2, etc.? They're not putting charge in there. What are they putting in there? Or they've changed Coulomb's law, which would be interesting. How have they changed Coulomb's law?
Here's the answer for our particle model. In fact, it's on our page called Principia Mathematical 2, and I'll make this a little bit bigger.
If you would, please.
Yeah. So basically, let's look at a couple of things in this model. We have a movement classification in our model. This model came about. Gravitic is a graviton, the traditional graviton model. Magnetic comes from Lionel Deneu's underwater experiments from 2008. Electric is just the flow of these particles. That's something I came up with, along with, inspired by. So all these things travel at the speed of light. We know gravity travels at the speed of light. Mainstream says that's the evidence for it. Magnetics, we accelerate particles at the speed of light. My dad came up with the idea of light is not, in fact, waves and particles, but waves of particles. And just like a shower massage. So that's how we came up with it. So this is how we classify it. So gravitic, this is a gravitic field. A gravitic field is anything that will make something curve or orbit, is basically caused by particles of the same quarter size that are bouncing off bigger particles like would be moons and suns, and that will cause an orbit. We know that's called by the shadowing effect. Well, if you look at, in our model, in this, you were asking how, if you look at Coulomb's law, here it is, F equals K, Q1, Q2 over R2. It looks just like the gravitational model, right?
Sure.
So a gravitic field, this is equation for the gravitic field. That's what we say. It's a movement classification. These could be, galaxies could be moving and colliding and causing a gravitic field of gigantic objects that we can't see and don't know of. It doesn't matter. It's a movement of particles, whatever level of the universe you're at. So if you take that and you say, okay, Coulomb's law, which looks just like a gravitic field, is a gravitic field. The only difference is that when you have a nucleus and you have an electron, for instance, or you have two what people call charged particles, the gravitic field that's making these come together aren't the same particle as what makes gravity at our level. It's another particle, really a lot smaller, really a lot faster, and down, and they're going in random directions. So what we say in our model is the G2 particle. There's a particle that's smaller than the graviton, if you want to use today's language. It's a graviton, super small, going way faster than the speed of light, at a level way down in the universe, and those random directions of those particles causes orbits, including orbits of electrons, and that's it's all a gravitic field. This just happens to be at different levels of the universe. That's one explanation.
Sure. Have you looked at the work of Paul Laviolette's? I would highly recommend it to you and your listeners, where he would have, he defines the particles, for example, electron protons, in terms of subparticles, and these are reaction particles similar to chemical reactions. If you look at things like the brucillator or other reaction diffusion systems, you have reactants coming in, they interact, they create something else that diffuse out, and from that he's able to get a fantastic amount of correspondence to observations in both cosmology, astronomy, and physics, including charged particles. And a charged particle in his model is not like a solid ball. Instead, it's a region of reaction where things are coming in. In this region, they have some kind of reaction which transforms them into other things that diffuse out, very much like chemical reactions. So he can use the same equations as in reaction diffusion chemistry, which can also create stable bubbles, bubbles that move. And if you look at it, it looks just like particle physics, honestly. But it's similar in that a charged body is a lot of interaction of sub-quantum particles, and that's perhaps result from sub-quantum and sub and sub.
Yeah,
and sub.
Right.
It's really interesting work that he's done. Anyway,
Sure.
just throw that out.
And I'll tell you, Bob, I've seen that more and more and more and more and more, is that this idea of an ultimate particle doesn't make sense, right? It doesn't make sense because if you think, even when I'm talking about people, when my friends who aren't physicists are not like you and me who like science a lot, and we're geeks, right, with that. They ask, well, what do is there like one particle that makes the universe? I go, think about it. If there was one particle that made the universe, how would it know how to do it? Right? What would cause it to organize itself? And I think that's one of the reasons a lot of the infinity is now being looked at, is because there's things below always to get this where it's at. So what you're talking about in this guy's model sounds like he is in a Borcher's infinite model, universe model.
Two things I'd like to mention from R. Buckminster Fuller.
Right.
One is that there is no static anything. Everything's dynamic.
Right.
I seem to be a verb, not a noun. The other is everything that you think you see is pattern integrity. Whatever is behind anything is very dynamic, and what you are perceiving is a persistent of a pattern, which allows you to distinguish it from other things. This pattern is different from this pattern, and so I can distinguish this from this. But it's not a static. It's not a noun. Right. It's a verb. It's dynamic. So I've always found R. Buckminster Fuller's writing to be very interesting, both in the language that he used and the conceptions that he brings forward. It's fascinating.
And what you're saying from what he's saying is very much, this is what Glenn Borcher would call all matter is in motion. All matter is in motion. And that motion creates all the things. And the patterns you see are like what I was talking about, the fractals. If you look at a fractal, and we as human beings, we take a picture of a fractal, we see a pattern. But what we are seeing happens to be at our, what we call, what I use Borcher terms, our unicosm, where we happen to be. If we go in on that, the whole thing is changing constantly. So our perception, so Buckminster Fuller, I think what you're saying is, are you part of the structures group?
I am not. I'm well aware of Don and his work. I encourage that a lot, but I'm so busy with my own stuff, I can barely, get here and provide comments. Anyway, I really appreciate the work that you and the organization is doing. And
thank you.
I'll let somebody else have a chance to talk for a while.
Okay, but thank you so much. Great comments, actually. I think what's quite remarkable to me is all the people who are seeing very many similar things are happening, folks. Similar things are happening. One of the things is they always here. I'm going to tell you before I bring somebody else on, because I've been around this since over almost 30 years. It's really interesting. One of the biggest criticisms of the dissident world, of critical thinkers is that we don't have consensus, right? What we have is a bunch of salesmen and no buyers. We have Dave DeHilster and his father. We have Jeff Yee. We have Lori Gardee. We have Dr. Lucas. We have all these people. We have Franklin Hugh with his model, his ether model. We have Duncan Shaw with his, I call Vancouver ether model. All these are models. We have Bruce Nappy, who has a lattice type of model. We have the other guy, Alistair. He has a lattice type of model as well. We have all these people and no one agrees on anything. And we don't agree on the details, but we're starting to agree on many things. And one of the things that if 10 years ago we didn't hear a lot and really didn't see was the infinite part of the universe and how infinity plays a role in that there is no ultimate particle, that there are no partless parts, as we say. You can't find something and then say, oh, this is it, there's nothing else, and then it will organize itself. So infinity is showing up a lot. And recently, no charge, that is, if something is moved, if you have a Coulomb's law, if you have an electron and a proton, and they move together, you can't just put a plus on it and just put a minus on it and then say to the world, oh yeah, they move together. And then even the average person on the street is going to say, well, what is that? Well, it's charge. It's just an innate thing. So charge, as trying to describe charge in physical terms, in Newtonian terms, is another thing that's coming about in a lot of the newer models. I'm not saying in the other models or the older models, but the newer models. And the idea of a Newtonian world, that Newtonian physics can describe everything. There's no quantum, there's no dimensions, extra dimension, there's only 3 dimensions. These are some of the things that we are currently seeing. You don't have to agree with them, but I am telling you now that the best models I'm seeing out there are dealing with that. Now, it doesn't mean that all models are that's what they're dealing with. You have Dr. Lucas, and he's here in the green room. He's working on a model, and he has shapes of the way things are. They're toroids, I believe he has. Someone did mention, David, the particle model can't describe helixes. Not true. We have a way to describe the right-hand rule in electronics. My dad's an electrical engineer, and the right-hand rule is caused by spiraling particles going through the atomic structures set up by nucleons. And when you set that through in a G2 gravitic field, just a regular gravitic field, you get spirals everywhere, because if you were to set up planets in the universe in such a way and you sent stuff, you're going to get spirals. So spirals are easily described by gravitic fields. So anyways, that was a thing. But I just want to let you guys know, one of the great criticisms of dissident science is that there are no agreed upon ideas. And another one, I'll give you another one. Energy is a concept, and it's a very useful concept. Force is a concept. It's a very useful concept, but it's a concept. These are things that we have as concepts. For instance, they said mass is energy. Well, that's I equals mc squared. What does that mean? If you don't have a physical model for the universe, it doesn't mean anything. That's the way a lot of us modern critical thinkers think. This is mass. Oh, it's got so much energy. What does that mean? I mean, what does that mean? And it has to do with energy is a concept. In fact, one of the ways I tell people is, tell me what the units are. If energy is a thing in the universe, tell me exactly what the units are, and are they the same everywhere? And they're not. The energy units are just ridiculously different for whatever you're looking at. So let me take a look at some of the new comments. We got, Franklin. I don't know. If I let him back, he may take over in a subversive move, click me out of here, and have a coup. So, but I will trust he is not that way. He's a dear friend of mine. He's a very kind person, so I don't expect, although he likes to argue, but I'll bring you up. Franklin, come on back. It's good to see you, man. How are you? Have you been
great.
Have you been enjoying your vacation away from having you slaved on Saturday mornings? Like, you can go out and cut your lawn in the morning instead of being...
No, like you said, I'm addicted. I still show up here, so...
Oh my gosh. Well, you know, do you have a good therapist?
Do I have a good therapist? No.
Yes, to work on your physics addiction. So
No, I enjoy my physics addiction.
Okay, but I
But I
need you to
wanted
get your. Yeah, go ahead. Go
I
ahead.
wanted to take us back to expansion Earth. So I
Yeah.
did notice that Wikipedia does have an expanding Earth page, and they do mention Dr. Maxlow,
Really,
and
because that's different from when I did it. Because I tried to add it. If you go back in the history of the Expansion Tectonics plate, you'll see that I put it in and they took it out. So
now
that's
his name is in there now. If
so
you take a
it's
look, maybe you can
changed.
bring that up. And
Wow, that's great.
he says that the remaining proponents after 1970s, like the Australian geologist James Maxlow, are mainly inspired by Carey's idea. So they do have some things about the history of
Right.
expanding Earth. Although they do have another section here that says main arguments against Earth expansion. Now, unfortunately, Dr. Maxlow is not here, but I was kind of wondering, have you heard about how he responds to these objections?
Yeah, I've talked to that's a good question.
So specifically, the measurements with modern high-precision geodetic techniques and modeling and measurements by horizontal motions of independent grid panels, blah, blah, blah. They do things with satellites, and these things are important because they want to figure out, like, whether the mass of the ice sheets is changing or the sea level is rising. And, of course, figuring out those things you would need to have a pretty good idea of what the Earth radius is, I suppose. So
Right,
I kind of wondering, did you hear about, how does he reply to those objections?
Well, I think there's two parts of that question. Number one is who is objecting, and number two, what
People
are these?
like NASA.
No. But let me just say, because plate tectonics used to be a something that in the 1960s and before the 1960s it was there were people in plate tectonics. What he says today. So I know what you're saying, NASA. But let's look at plate tectonics, right? Because if you look at the two things, what do you have? Plate tectonics and expansion tectonics, correct? That's what we're looking at. The problem is plate tectonics in the university world, as he says, almost doesn't exist. It's in the earth sciences. There's people in the magnetic side of it, but people are not getting degrees in plate tectonics. It's the same way with relativity. People don't get degrees in that. You don't go to any university ever anymore and get a degree in it. So plate tectonics is sort of something we talk about like relativity that people don't study. So we can't have a conference and invite the top plate tectonicists there. We can talk about people who look at it like NASA. NASA aren't geologists. At NASA are doing measurements. So the first thing is that plate tectonics itself, according to James Maxlow, is being totally propped up by history. It's not being propped up by people who study and argue against expansion tectonics. So that's the first thing. If you were to talk to people on the street and say to them, "Look, we have plate tectonics in Wikipedia." Well, who are the main proponents of that? You don't see anything. You see literally Carey, who died in the 90s, right? You don't see, or I think it's 2001 or something. You don't see, here are the schools where plate tectonics is done. Here are the models. You don't see that. And the reason you don't see that, according to many of us, including James Maxlow, is when you start to look at it, it falls apart like relativity. It falls apart in front of your face. So what are we fighting is the history of plate tectonics. And the history of plate tectonics is in the 1960s. We could have gone one way or another. At that point, Samuel Warren Carey and the older geologists who were people who were looking at, they were geologists who had in front of them for the first time that there were plates, and plates were moving, according to them, not the expansion going on, but they were moving. So in the 1960s, the geologists at that time, who were older, the mainstream people, had this notion by Carey and other people, I think it was Werner or somebody before them, who put up the idea that plates were moving. There were plate tectonics, that they were moving. The tectonic shifts, we even use that in English as a word for meaning gigantic shifts in something. At 1960s, what James Maxlow said, and also Hurl, he's got a book that I recommend everybody read, and you can get it in this book here. So if you want to read about it, in the 60s, these old geezers guys like myself now, I'm 61, they had in front of them this idea that, oh my gosh, the Earth isn't just a static thing, that there are plates and they move, or there's movement there for some reason. And then that was already a super shock to their system. That was a huge shock. Right along on top of that was the idea that the Earth was expanding, which of course is even more shocking, because where does the expansion come from? Where does mass increase come from? And so at that point, what Carey says and what Hurl says is basically they said, okay, we were barely even trying to think that we're going to accept plate tectonics, and now you throw expansion tectonics. Forget that. That's crazy. The idea that the Earth was smaller, throw that out. Well, we'll go with the plate tectonics. They went for it for a while. The 60s had a lot of that, where they did the seafloor bed, the 60s and 70s. They got the evidence. At that point, there weren't just, the people just started dying off, because when they started looking at all the evidence, it just didn't, it didn't add up. Plate tectonics, Pangea. Look at the problems with Pangea. My goodness, Pangea problems are huge. So what I'm saying is that from 1960 to today, plate tectonics has been, like relativity, even from earlier on, has been abandoned. There are no degrees coming out in either of those fields anymore. People do not get degrees in relativity. People do not get degrees in plate tectonics. I can't remember the field that James says about that, but that's one explanation. So what is being fought on in Wikipedia isn't a organized group of people who are plate tectonicists. They're not there. They don't exist. There's a few here or there. It's like relativity. You got Kip Thorne.
Well, I think if you take a look at the papers, that's what kind of surprised me, because the papers start out by saying they do recognize the historical significance. I mean, some people were thinking that the Earth was like changing in size, smaller, bigger.
Right.
And so certainly from these researchers' standpoint,
Right.
that they are willing to accept that
Yes.
this might happen. And they're
Right.
doing a serious scientific study to determine, what is the actual rate that we can actually measure using our finest thoughts and satellites and
Right. And I understand. Yeah.
And they're coming up and saying, okay, we've measured it, and to the degree that we can measure it, it's like it's not changing any more than like half a millimeter per year.
Right.
Or
And
it's
there's
statistically insignificant. So
yeah.
I mean,
Well,
that's an interesting result.
Right. Well, I have an answer for that too.
Maxwell, addressed that. I mean, these papers are too complicated for me to determine, the veracity of what they're doing. I mean, some of these things are like just like confirming ideas like subduction happens, and I say, sure, subduction happens, but that certainly doesn't explain a lot of things, like why doesn't it subduct on the other side of the Pacific Ocean, where you've got all that old Triassic stuff you think was expanding it.
Well, let me answer the question, and there is an answer to it. And there are two people that would answer that question, and one of them is James Maxlow. But I'm going to give you another person who just recently died, a very good friend, and it was very sad. I think it was last year he died. It was Ron Hatch. Now, Ron Hatch knew about expanding Earth. And the problem with the measurement of an expansion of Earth is that when they are measuring, what they have is a measurement from the satellite to the Earth. And that is not something that they're not looking to measure the distance. They don't look at that so much. In fact, they put these things into orbit, and they're orbits that are close to where they want to be. They know and they calibrate these things. So you basically go to a close orbit the way you can get to a close orbit, You calibrate it to do the measurements you need to know. And what his job was to get the tractor on the field to stay within centimeters of where it needs to be. Why? Because if you do that, you're going to waste a lot less energy, right? Because if you're going to go all over the place and you're overlapping, you can save a lot of money if you're doing immense amounts of. So that's one of the things he did. So he said that the actual data to try to find whether the Earth is expanding via satellites is very precarious at best. And the reason is because there are no satellites out there. They have satellites that measure a lot of things. They even measure movement, but to get the actual size of the Earth, to give you an example, the other things that is mentioned, and both Ron Hatch and both James Maxlow talk about, is that the Earth's shape and size is different all the time, because it is not a solid rock that when it moves 1 centimeter, that it's whirling around, things are changing on it. It is a plastic thing, and that its radius is not the same every day. So the problem is the measurements that are needed are so small, and that we did not do a constant, what Ron Hatch says, and I go more by him because he spent his whole life measuring, right? And what they were measuring was very different things, positions. They were not trying to measure he said, to do the radius of the Earth and the change of it is a whole different beast. The data that you have is not most likely going to give you any indication. You're going to have to make a lot of assumptions. Those assumptions are going to be off by millimeters. And unfortunately, millimeters per year is what we're talking about. Because that's all. So what James Maxlow and Ron Hatch would say, they would, on this very first one, measurements with modern high precision geodetic techniques, they would already question whether those measurements are really measuring what is needed to find out whether the Earth is expanding. Both of those gentlemen told me that. And so
one of the interesting arguments that I heard of, if you try to put like a tape measure around the Earth. Now, I think they've tried to do that, and they have to use it at certain stations. But the problem is that the Earth's surface itself is actually rising or falling, and that is changing the distance all by itself. I mean, even if you could put like a set of radio towers around the Earth, and you send radio signals and measure the speed of light and all that stuff to try and that they have to kind of try and subtract that.
But I think
complicated.
Right. And I think what really needs to be done is a concerted effort to really try to measure what this is. And I think that's what both of these men are saying. You can't use today's data and try to come up with the answer, because the data you're getting isn't what we are needing to do that. Now, of course, what you're saying is true, and I agree with you, and I think that's a great observation you made, Franklin, is when you look at these arguments, people are more and more looking at this, at expanding Earth. There are some people that say there's expansion contraction, but the expanding and growing Earth is becoming more and more prevalent and accepted. Just like that video we saw early on today of this guy who's not even expansion. He's not a geologist or anything. He just saw it and did an analysis of it. Like what's his name from our group always does. Gosh darn it. He's the guy who always does analysis of all of our models to see if it's right. Ray Gallucci. Yeah. So Ray, so the other thing is too, and I think you will agree with this, is that when you look at this, before Expanding Earth didn't have these sections. 5 years ago, when I tried to even put in the name James Maxlow, you can go literally back in the history, see where I put it. Was a bunch of years ago, and someone removed it. Now you told me that they have his name on there. That's already a movement forward. They're allowing that, right? The other thing is too, and maybe you will agree with me, a lot of the web pages, because they are stuck in only looking at what mainstream says and treat any other idea as pseudoscience, that what they are doing in main arguments against Earth expansion is what I call a very focused, we don't believe this is not mainstream, so we're going to find any argument we can to go against it, whether or not that is a preponderance of evidence. That is, if you were this main arguments area, I'm going to put that up again, this main arguments area on right here, you have measurements of geodetic, that's one. Motions of plates, imagings of fragments, paleomagnetic data, which actually is not good because paleomagnetic is much more for an expanding Earth. So these are cherry picked. What they don't talk about how Pangea is a better model than all the continents together. They can't. It doesn't work. It would fall flat on its face. So what you are seeing are one good thing and still a vestige of people arguing against it just because it's not accepted.
I was thinking just a little mindstorm here is that we've got transatlantic and trans-Pacific communication cables going across the planet, and that at least connects a big part of the planet, which we could measure with light waves. I would think that if the Earth is expanding as much as they say, that would actually become kind of a practical problem, that it would be stretching the cables.
No, they do take into account across the cables across the Atlantic, and the way they do that, they lay them in a way that they're never in a straight line. What they have is
snaking around.
Yes, they do that on purpose.
If it gets a little bit wider, it's probably not going to notice. Right?
They lay it out pretty straight, but they lay it out in a way that they know that there's give and take with it, so that when there is expansion, to give you an idea, I believe the Atlantic, and I'm not certain, but when I first started studying expansion tectonics, in your lifetime, the Earth will expand your height, more or less, is what you'll say. And the Atlantic is supposedly expanding at 6 millimeters a year, whereas the Pacific is anywhere from 18 to 23 millimeters. That's a lot. It's like,
that's a lot. You think that would be measurable over just a year's time?
Yeah, but and like you said, and you're totally correct. Try to measure the Earth. It's a plastic thing. I mean, the Earth is really much more plastic. We have earthquakes, and they go through our Earth-like waves. It's waves. I was in California. When I was living in California, I lived through. It was the earthquake in '92 or '94. We were woken up by the earthquake. It went on so long that we went up to our third floor because I said we had an artist's loft where I lived. I was in that, and I looked across. I was sitting with my wife, and I'll never forget it. The view we had was between all the houses going downtown to downtown Long Beach. On that view were all the telephone poles, the power poles that gave electricity for our block. And they were literally doing this. You could literally see the sinusoidal waves. Now, the Earth is not a solid rock where you try to move it and it won't move. It's a very plastic thing. So the problem with measuring it at such small measurements is you can measure it 1 year and get one reading and measure another year and get another reading. It's really hard. I think there's going to have to be a concerted effort by our community or a community to actually try to measure it. And what do we put our heads together? Because like you said, if it's expanding over here more, this year Iceland will spread out half a centimeter. Next year it'll be a half.
My point is that I think for the Earth expansionists, they need to study those things, and like maybe suggest such an experiment that would, kind of clearly.
Yeah.
I don't know how you would do that, but maybe some clever engineer might be able to figure out some very clever experiment they can do to show that the net radius is actually increasing. It's kind of like a purpose built, because like Ron said, it's like there's so many things going on. You may not be able to use the existing GPS satellites system for that, but if you guys can build something special to do that, then maybe you can measure it. Because looking at those papers, maybe there's so many things.
Exactly. No, I agree with you. I think what's like I said, the two important things are, one, Maxlow's on there. Number two, when you go to the references, like you said, they're talking about expansion. And number three, we can see they're cherry picking. Like you said, you can look at the data, and we who are critical thinkers, we're the first ones to say, hey, this is suspect. You can say this is evidence against it, but look at how you're doing it. If you do it this way. But I think the really interesting part that you're coming up with, Franklin, is that with James Maxlow with Expansion Tectonics, we have our group and we have the structures group, which is doing their own thing, their own website. They're part of our group in the sense of they're members, but they're doing their own. The other one we're going to be working on is expansiontectonics.com, and we're going to have the same kind of community there. There's two projects now that we can look at. One would be, and this was Franklin coming from you, can we come up with, as a community, a way where we could perhaps find data that we could definitively say that there's expansion going on? But we'd have to get people's heads together and get together like we're doing now. We could have
both $1 billion experiment. People love those.
Yeah, exactly. And because you are independently wealthy and never told anybody, and you're a child.
This is where we get money from the government, right? Okay.
Right. Yeah, the government will do it. But anyways, I think that's interesting. The other thing that I want to do in the Expansion Tectonics is to take Google Earth software and modify it so that you can put in times, and it will correspond to the radiuses as predicted by Maxlow and other people. He's got an equation for it, and then be able to plot at that time, right? So you can make the Earth at that time and plot the flora and fauna, and then plot it at different times. And I think that's another interesting project. So what we're going to do is we're going to assign Franklin Hugh, our director of securing of grants, for doing some of these projects. So go to it, and we'll be talking next week with Franklin about what grants.
We've got James Maxlow in the wiki now. See, so there must be some movement forward. So someone did not erase that whole section, and certainly the pundits have their objections against, but probably until you can have some super scientific experiment confirming this, probably it will kind of still remain in the background.
Sure.
Because I think like the positive evidence for it seems pretty clear.
Right.
But I have to remove the remaining objections.
Well, I think but here's what I think that really happens, and I understand what you're saying. The objection of there's no mass increase mechanism, right? Here's what I think.
I don't really consider that an objection. It's like so what?
Well, no.
That doesn't
I know.
Right?
Right, but what you said, your hypothesis is that it's going to happen when the objections go away. I think it's different. And I think what's happening is different. It's the preponderance of evidence, whether or not you believe how it happens, if you know how it happens or how much or whatever. The preponderance of evidence is overwhelming. And most people, when I talk about it and they look at it in a very short amount of time, they're going, "Oh yeah, this makes total sense." It's creepy to think I'm standing on a ball that's getting bigger, but that makes sense. I think what's going to happen is eventually the number of people who will know about it will eventually push it over the edge. So much so that people will write about it almost as fact eventually, even though there are all these objections. Those objections disappear when you have all the logical evidence out there that shows that, there's
only one other comment I wanted to make about this expansion thing. So, one of the things is that they say that Earth is constantly bombarded by lots of space rocks and stuff like that. So that's one way of accretion, although it's far short of what the expansion Earth proponents say. Although what always has been curious to me, that if you go to places like the Grand Canyon and you see that the Colorado River has cut through all of these, layers and layers and layers and layers, which is thousands of years. My question is, how did all these layers get here if not by being piled on top constantly? So I'm thinking that, well, maybe that's not such a bad idea. If you dig into the Earth and you just see layer upon layer upon layer, sedimentary layers, the only way they can get there is, stuff falls down. Maybe the Earth is getting bigger.
No, the answer, there's a pretty simple answer, and that is you have life. You have life and you have chemicals, you have movement. So what you have is life, and the things that put down layers are...
but you see how much layers there are? It's like a mile's worth of layer. Going down into Earth, there's more layers below that. So I find it hard to believe that those kind of layers could be built up. That theoretically, the process is going on today, right? Additional layers are being put on on
But
what
it's
we're
not
seeing
from
right
space.
now.
Yeah, it's not from space. It's not from space. What's happening is just a transformation of what is
No,
here
it must be
already.
from the outside because it's more material, right? It's definitely more material.
Well, if you were to look at expansion tectonics, the way you explain it is in the beginning of the Earth, 4,000 million years ago, 4 billion years ago, is you didn't have lots of layers. It just didn't. It wasn't there. What happens with time as mass is increasing and you get secreted, now you have life going on. There's a process of changing. So the mass that's coming out in the form of the mantle lets go all these chemicals that are good for life. Life happens in the sea. Things fall in seas, in shallow seas. Before there were oceans, those things create the levels that you see. So when a geologist looks at those levels, the only ones that they see that have some were like 65 million years ago when this idea that this asteroid came in, you can literally see a radius, sort of a layer that came from outer space. The rest of the layers are life going on, and that were built upon that. Where did all the mass from all that came from? Oh, it came within the Earth from the mantles, the way they would say.
Or it could have come from space.
It's not enough for if you do calculations. There's just not enough to accretion. It's called, but accretion cannot in any way, especially the exponential increase, can't be explained by accretion alone. It just doesn't.
Yeah, I just as a skeptic find it hard to believe that because I've seen that 65 million year old line and you say there's like 10 feet above that.
Of course, sure.
That's a lot of.
But geologists, what we need to do is go out with a geologist one day and take them out. They actually, who does that are the Electric Universe people. When we were out in what was that? In Arizona, Tucson, not Tucson. Anyways, Arizona, we were out.
I still find it hard to believe. So
yeah, but what they would do, they would have field trips out into the wilderness there, and they would go with geologists. And they were talking about electrical events, but geologists would be able to tell you what those they're all what they call sedimentary rock. So that's what I think. So, okay, well, thank you for your comments. And you have anything else before I bring you down?
Nope. Not unless you want me to talk about, turtles all the way down.
Well, we only have 5 minutes left.
Fundamental particle. I'm going to put my foot down on that one. So, there you go.
Yeah, but you have to explain to the world how fundamental particles have the magic of being able to come together to create a very complex world. That's the problem.
Oh yeah, just read my paper. I explain how that's done. It's easy.
Okay, all right. Well, I'll have you come and give a talk on that because I've never seen any explanation for it. So that's okay. If you have one, that'll be great. I'll take a look at it for sure. Because
maybe next time. Everything is built on the electron. So.
Yeah, I got you. Oh, got you. All right. Well, thank you, Franklin. It was great to see you, and thank you once again for all your help during those times where we were here. But we are now at 11:56. I'm going to probably have to call it a day here, and I do apologize once again. I believe it was the time change, and because it's so late, and Dr. Maxlow, I think, is maybe in his 70s, so they go. It's nap time for him. But I'll give you a taste of what's coming. I don't think it's next week because I think next week we have Dr. Glenn Borkert. But this is the advertisement for the forthcoming talk by Dr. James Maxlow. So fact or mere coincidence, that's going to be at a later date. It will not be next week. Next week will be, in fact, Glenn Borkert talking about the Big Bang, and that's going to be really interesting. The Big Bang has about as many problems as Pangea, and philosophically, and all kinds of real evidence for that. And of course, I'm David D. Hilster, and I'm with a Dissident Science, and I'm also with the organization, the CMPS, which I'll give you a little taste of what that is. For those of you who don't know, that phi, I think it's called phi, is the Greek letter for the first. This is really interesting. It's the reason we picked that as our logo. In fact, let me get it up there. Branding. Where is it? Right here. You can see it up there in the corner. Right there. I've learned to point opposite because what I see in as the broadcast goes the opposite. But right there, that Greek letter, I think it's called phi, is interestingly, it's the first letter in the word philosophy in Greek, and it's also the first letter in the word natural. So natural philosophy actually has the same, so that's why we have that. Isn't that coincident? And it looks like a tree, so I put an apple underneath it. So anyways, I want to thank everybody, and I do want to remind everybody, please consider becoming a member of our organization. You can go to naturalphilosophy.org, and whoops, here, let me show you that. No, that's not it. naturalphilosophy.org, and you can sign up and become a member by paying an annual due. I'm going to be putting some monthly ones, maybe like $10. We do need your support. It's vital. We have our big in December, we have our bills coming due because we pay for our website servers. We pay for this monthly. We pay for Overleaf monthly, where we publish everything. So please consider that. Even if you're on a fixed income, a little bit for us is a lot. If everybody chips in, it is greatly needed. We don't. I would hate to say to you, well, folks, our website's down because we can't. We need to pay for that. I wish I was independently wealthy. We do have people who can donate. If you can donate, that is great. Also, just go to the page. It really supports this ability for us to be here and discuss what we discuss, what I discuss with Frank and what I discuss with Bob Gray. Where else can you get this? And if we don't support ourselves, no one's going to do that. And of course, do subscribe to our YouTube channels, both Dissident Science. I want to thank everybody, all my YouTube subscribers, and we're coming up to 1,000 subscribers on the natural philosophy. We're up 700 and something, slowly getting up there from when I first started worrying about this, and I'm almost up to 3,500 subscribers. So I want to thank all my subscribers. I'm hoping you guys are really enjoying these conversations, and of course you can join in yourselves. So again, thank you so much for everybody's support. And I am David D. Hilscher, your science therapist, trying to get you the promised land. Remember, stay critical, stay thinking. Ciao for now.